we are going to explain about a project titled Classification of Alzheimer's Diseases using RF Signals in Machines. So now coming to the introduction part. Alzheimer's disease, an advancing neurodegenerative condition, presents a notable obstacle within the healthcare and diagnostic domains. With the aging of worldwide population, there is an urgent requirement for cutting-edge technologies to assist in the early identification and categorization of Alzheimer's disease. A promising area of investigation explores the utilization of radio frequency, that is RF signals, in machine learning algorithms. The idea of utilizing RF signals for Alzheimer's classification originates from the recognition that shifts in the composition and the structure of brain tissue, which are indicative of the disease, might be reflected in changes to patterns in RF signals. So now coming to the objective part for this project is to improve the early detection and diagnosis process. The utilization of RF signals capable of capturing subtle alterations in brain tissue linked to Alzheimer's is intended to pave the way for a non-invasive and potentially more precise means of identifying the disease. The application of machine learning, especially through algorithms such as random forest, which stands for RF, stands out as a robust method for scrutinizing complex patterns present in the RF signal data. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project. Here first we have importing the packages. So here in this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and matplotlib and cbon for visualization are important. Second, here we have exploring the dataset, dementia prediction, that is RF signal values of Alzheimer's. This step involves loading and exploring the dataset related to the dementia prediction, especially focusing on RF signal values associated with Alzheimer's disease. Exploratory data analysis may include understanding the structure of the data, checking for missing values, and visualizing key statistics. Next, here we have data processing. Data processing involves cleaning and preparing the data for analysis. This may include handling missing values, encoding categorical variables, and scaling numerical features. Next, here we have visualization using cbon and matplotlib. Visualization is crucial for understanding the dataset. cbon and matplotlib are popular libraries for creating insightful visualizations, which include histograms, scatter plots, and other types of graphs. Next, here we have splitting the data to train and test. To evaluate the model's performance, the dataset is typically split into training and testing sets. The training set is used to train the model, while the testing set helps assess how well the model generalizes to new unseen data. Next, here we have building the model. This step involves creating and training machine learning models using various algorithms. Some algorithms mentioned include support vector machine, random forest, J48 decision tree, logistic regression. Next, here we have LDA, which stands for linear discriminant analysis, KNN forest decision tree, XGBoost Gaussian knife base, SGD booster, and voting classifier. Then next, here we have training the model. The models created in the previous step are trained using the training data. Training involves adjusting the model's parameters to make accurate predictions on the training set. Then next, here we have building the model with voting classifier, since it gives better accuracy comparing with other models. The voting classifier is chosen as the final model due to its better accuracy comparing to other models. A voting classifier combines multiple models to improve overall predictive performance. Next, here we have class framework with SQLite for sign up and sign in. This step involves setting up a web application using the Flask framework, incorporating a SQLite database for user sign up and sign in functionality. Next, here we have importing the packages. It is similar to the step 1. This likely refers to importing the necessary packages and libraries for the Flask application. Then next, here we have user gives input as feature values. User provides input likely in the form of feature values related to Alzheimer's prediction. Then next, here we have the given input is pre-processed for prediction. The user input is pre-processed to align with the format expected by the trained machine learning model. This may involve scaling, encoding, or transforming the input data. Then here we have trained model is used for prediction. The pre-processed input is fed into the trained voting classifier model to make predictions about the likelihood of Alzheimer's disease. And the last one, here we have final outcome is displayed through front end. The model's prediction is communicated to the user through the front end of the web application, providing the final outcome of the Alzheimer's prediction. So now coming to the execution part. To execute the project, first we need to open the code folder. So here you can see that Here is a folder which is named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. Then next folder here we have static. This folder consists of files related to CSS, JavaScript and Bootstrap files. Then here we have .ipynb file, which is a Jupyter file which contains a combination of code, graphs and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. The next here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database and generating dynamic content to be rendered in the HTML templates. And then here we have signup.db file. This file appears to the database file which is used to store the information. So now just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and just paste the path over here and now hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. Here I am using Chrome. Just paste the link over here and now hit the enter button. So here you can see that this is our home page for the classification of Alzheimer's disease using RF signals and machine learning. Here you can see that there is a button for sign up. Just click on it. This is the registration form. Just enter your username, your email ID, your name, your phone number and your password over here for doing the registration. I have already done the registration, so here I am clicking on sign in button. So this is our login form. Just enter the username and the password over here which you have created while doing the registration and simply click on login button. Click on OK and here you can see that it is showing the number of digits to detect the dementia status. So just enter the number over here, enter the mr.delay, enter the gender, handedness. For female you have to write the gender as 0, for male you have to write the gender as male. So here I am entering 0. For age you have to enter the 1, enter the years of education 5, enter the socio-economic status as 4, mini-mental state examination score 1, for the group as 4, estimated total intracranial volume as 121, for the normalized whole brain volume 21 and for the Atlas scaling factor as 5. Here you can see that there is a button for submit. Just click on it and you can see the outcome as based on the RF signal the patient is not affected with the Alzheimer's disease. So depending upon the parameters you have provided over there, it will showing the outcome as whether the patient is affected by the Alzheimer's disease or not. Here you can see that there is a button for about. Just click on it and here you can see that there are many different graphs and based upon the algorithms we are using over there, it is showing the accuracy over here. Here is a button for sign out. Just click on it. You can successfully log out with this. So now coming back to the conclusion part. In summary, combining radio frequency, that is RF signals, and machine learning methods for Alzheimer's disease classification signifies a revolutionary strategy with profound implications for diagnosis and unraveling the intricacies of the disease. The non-intrusive method of acquiring RF signals holds great promise for early detection, potentially breaking ground in the identifying Alzheimer's in its initial phases when interventions may be more impactful. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.